All right. So good morning, good afternoon, everyone. Welcome into another broadcast with us here at Exploring by the Seat of Your Pants. I know quite a few of you are familiar with the work we do, but if you are new to us, we are all about bringing conservation, adventure, and science into classrooms around the world. Now, everything we do goes to our YouTube channel and stays there forever. So if you want to share this with your friends or family in 3 weeks or 3 years, you can absolutely do just that and catch the remaining programs in our epic Our Changing Planet series. So we are partnering with the amazing folks at Environment and Climate Change Canada to bring together a week-long extravaganza featuring some of the coolest scientists in their network. We've had people talking about monarch butterflies just yesterday with Greg Mitchell. We've got Arctic biologists and explorers. We've got people working to save species and protect our water systems. And I'm so excited to have this broadcast. It's our first of several series with Environment and Climate Change Canada coming this year. So if you want to check out more, head to that webpage below. Today, I'm really excited because we are bringing back Zen Mariani. He gets to go to some of the most remote and amazing regions on planet Earth. Happen to be in Canada, but truly, like on a global scale. This is some really neat stuff. Do some really cutting-edge science to study Arctic weather and climate. Without further ado, I'm excited to bring him back. I'm going to stop talking. I'll turn you over to Zen to blow our minds. And thank you so much for coming back to the broadcast, man.
Great. Thanks so much, Jesse. It's great being here.
Yeah, I know you've got a lot to share with us. If you want to dive right in, I'll put myself in the background here and we can get on with it.
Perfect. Okay. Well, thanks, everyone. And I guess a big virtual hello. So today what I'm going to talk about is some of the work I've done. It started at work that I did in school, so when I was in university, and then it slowly and surely became my career. So this is what I'm doing today. It's kind of my job now. So I'm going to talk about studying the Arctic weather and climate. So I am a research scientist. I work in the High Impact Weather Research section in the Meteorological Research Division at Environment and Climate Change Canada. So essentially that means I'm a scientist. I do a lot of analysis and physics and math, and my sort of sandbox is to play in the Arctic and to study the weather and the climate that's happening there. So go to the next slide. There we go. So I'm from Toronto. So I finished my high school and then I went away to university. So I went to University of Western Ontario, or Western University it's called now, where I studied physics, and I studied business as well, but I really liked the physics. I really liked the science. So I drifted towards science more than business. And then I decided I was enjoying what I was doing so much that I stayed in school. So after university, I did what they call graduate school. So I did my master's, and then eventually my PhD at University of Toronto. And after then, after a couple of jobs in the private sector, I eventually became where I am now. So I'm a research scientist in the Meteorological Research Division. So this is basically weather research at Environment and Climate Change Canada. So why was I studying climate change and now the weather in the Arctic? Well, the first and kind of scary reason, actually, is that what we found is the Arctic is warming faster than anywhere else on the planet. It's actually warming twice as fast as anywhere else on the globe. And so the measurements in the Arctic help us to better understand this changing climate. So why is it warming so quickly? What's happening up there? And my PhD research at the University of Toronto was I was looking at taking brand new measurements of infrared radiation. So infrared radiation is a fancy word. You can think of it as heat near the North Pole. So we had a special site right near the North Pole, and that's where we were taking these measurements because that's where we're seeing such alarming increases in temperature occurring. And the Arctic is really important for a number of reasons, but this figure kind of shows one of the reasons is, well, we've got this, what's called the Northwest Passage. So this is where, as the sea ice melts, all of a sudden cruise ships and transport ships can take this passageway through the islands. This is the Arctic in Canada, and they can get from one side of the country to the other. So this Northwest Passage is opening right now. It's actually open in the summer now, which is never used to be. And that's because the sea ice is melting so fast. So when I was doing my PhD, what we would do is we had a special site up in a place called Eureka. So this is the North Pole here. This is, northern Canada and the Arctic. And so our site is right here, very, very close to the North Pole. It's on a place called Ellesmere Island in Nunavut. And what we would do is we'd fly to this site in Eureka. And specifically, I would work at this building here that you see at the top here called Pearl, which is the Polar Environment Atmospheric Research Laboratory. So we would fly into Eureka, which is at the letter A here, and then we would take a truck every day and drive up this sort of mountain cliff up to Pearl. And to give you a sense of, well, what's there? Where are we flying into? There's nobody who lives here. There's no town, there's no people, there's no schools, there's no buildings, there's no police station. To give an idea, the nearest McDonald's or Tim Hortons is far, 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 far away. You have to fly there. You can't get McDonald's or Tim Hortons. You're completely on your own when you fly up there to do your research. So how do we get up there? Well, we board a plane, looks just like this. And we usually board in Yellowknife in the Northwest Territories. And then what the plane has to do is it has to sort of hop from island to island, refuel, and then keep going north, because northern Canada is massive. And it can be easy to forget just how big our country is. So I fly to Yellowknife, so that takes a day. Then we hop on the small plane, and then the plane hops from island to island. So it could go from Cambridge Bay up to Resolute, and then there's Eureka up there circled in red. So it takes a long time. We're adding a whole day to just get to Eureka, just to get there. And to give you a sense, this plane is not like a plane you've ever been on. You know, you're not flying in this nice, comfortable Air Canada plane where they serve you water and food. In this plane, it's unpressurized. It's loud, so you can hear the engines blaring in your ears. It's freezing cold, so you have to board the plane with your winter boots and your parka and your toque and your mitts and everything. And because it's so expensive to get there, we have to cram the plane full of all your equipment, all your science gears, your tools, your backpack, your clothes. And so all that sits up in your lap, your knees are in your face, it's loud, you're on the plane for 8 hours. There is no bathroom, there's no washroom on the plane, so you've got to hold it. It is a very, let's put it this way, fun plane ride. You're landing on the snow and the ice before you finally get up to Eureka. But it's worth it, because when you're there, this is what it looks like. So this is the view when you're on top of the mountain at Pearl. And this is me looking north. So you can see the sun in the distance. This is actually sea ice. It's completely frozen. This is late winter. So this would be late February, early March when I was up there. You can see everything's covered in snow. Everything's completely frozen over. And it is cold, but it is beautiful when you're up there, that's for sure. Because, I mean, this is truly unique scenery. Humans don't really live up there, so you're seeing something that a lot of people don't get to see. So this is the truck that gets us around. This is the station at Eureka. These are the windows. You can see the bedrooms are inside, so I sort of sleep in there. This is the big kitchen that you can see in there. You eat your food, and then you come out, get in the truck, and the truck would kind of drive you around to where you need to be. And I think you can notice something a little different about this truck. It doesn't quite look like the trucks you might see in and around your towns. There's something special happening in the wheels here, and that's just, there's so much snow and ice that we have to deal with. When you get to Pearl, it's a facility. It's really a world-class facility that's equipped with a whole bunch of instruments, most of which are for observing the atmosphere. So I've listed a bunch of instruments on the roof of Pearl that collect measurements, sort of either requiring someone to go up there and program it, fix it, or they do it fully autonomously. They just constantly are taking observations of the weather, they use the sun in some cases to take the measurements of gases in the atmosphere. There's also other groups that take astronomy observations. So if you want to look at the stars, it's actually a great place to do it up in the north because there's no light pollution and there's no pollution up there. Well, very little, I should say. Now, it's really unique when you go up that far into the Arctic, particularly close to the North Pole, because you get to see the extremes of different conditions. One of which is they have something called polar day and polar night. So if you go up in the Arctic in the summer, you're so far north that the sun never sets. So this is a good time-lapse image of the sun, and all the sun does is it kind of wobbles up and down, but it never sets. So this would probably be around midnight or 1 a.m., 2 a.m., and it's still sunny up there. So you can go outside and the sun's out. It's really weird. It kind of messes with your mind. And then if you go up in polar night, which is what I was doing, this is what you see. The sun never, ever comes up. So it's always dark. You always need your lights, and it can get a little scary, dark, depressing, depending on how you want to take it. So you never see the sunlight if you go up in the winter time in the Canadian Arctic, which means you're experiencing some really cool, literally, conditions. So there's about 4 months of polar day where you got temperatures of it can get up to around 15 degrees Celsius. It can be surprisingly warm. There's people when you're up there at the site that can walk around in shorts and a t-shirt. And then in polar night, so if you go up in January, February in the winter time, it is cold. You get temperatures around minus 45 degrees Celsius. It gets even colder than that. And it sounds weird, but the Arctic is a desert. So there's very little precipitation, very little water vapor in the atmosphere. And another thing that you note in some of these pictures is you're so far north, there's no trees. You're north of what's called the tree line. Trees just can't grow up there. It's too cold. There's not enough water. Another thing when you're up in the Arctic is it is extremely expensive to do research up there. So because it's so expensive, it costs a lot of money because you have to ship everything up there by plane, which means, something as simple as an orange juice costs around $30. So it is very expensive. You have to be very careful what you bring and how much of stuff you're bringing. And then, of course, because you're up there, it's so cold, you have to pack accordingly. Everything freezes when you're up there. So even your eyelashes freeze, the hair in your nose freezes. The air that you breathe out condenses around your hat, and that freezes. So it's a very different environment. But when you're up there, you get to see the wildlife. So the wildlife, when you're up in Eureka or the Arctic in general, they're not really used to humans. This is sort of their land. And so when they see you, they're curious. So on the left here, this is an Arctic wolf that was kind of checking us out and followed us. And this is an Arctic wolf, and on the right here is an Arctic fox. So really cute little guy that was trying to eat some of the food that was left around. And you get some great scenery. These are Arctic hares, so the rabbits. And there's a lot of them when you're up there. And actually, from a distance, you can't even see them. They're so well camouflaged that they just blend into the scenery. So it's actually difficult to get a good glimpse of them. Here's more Arctic wolves. You get some spectacular sunsets, which is what you can see at the bottom left here. And that's because of where you are when the sun starts to go up in the springtime, the sun kind of hovers as a sunset for hours, which, you get some great visuals that way. You also get something called sundogs, which if you see this arc around the sun that you see here, that's not the effect of the camera. That's actually a real effect caused by, it's called diamond dust or ice in the atmosphere that reflects the sunlight in this special way. And then, of course, because you're up there, you're so far north, there's a lot of really cool, fancy scientific equipment for communications, for everything to try to bring your scientific data down south. Here's some more pictures. That's the Pearl Lab, again, in the wintertime. And then here's some photos of me. Again, here's a good example. If we have to strap lights to our head when we're working outside, because if you're up there in the polar night, there's no light. So when you're working on your scientific instruments, which is what you see here, we've taken off the shelters and we're inside working with the electronics, you need to see what you're doing. But then also it's extremely cold. So you have to be careful because if you're touching metal at minus 50, you can get frostbite very quickly or your hands can stick to the metal. So it's not fun, but it is fun, I guess I should say, depending on how careful you're being. So for my project, one cool thing that I was working with for my PhD is I was using an instrument that's part of a network. So when you're doing a lot of this scientific research, sometimes you have a very unique instrument that's all on its own, and you're the only one who has it. And sometimes you have an instrument that's part of a network, and it could be deployed all across the globe. So I was up here in Eureka working on my instrument, and there were identical instruments located in, across the planet, essentially, for different countries and different research groups looking at different things. And since then, there's a lot more of these instruments that have been deployed. So this is actually somewhat outdated when you take a look at this map now. So that's what I was doing for my PhD research. And now for my current position, I work with what are called integrated observing system technologies. So that's a really fancy way of saying we have all these different technologies. How do we put them together? How do we take good pictures of the atmosphere or to good measurements of the atmosphere using different instruments that look at different things? And so this image does a great job showing what's currently available to us if we want to take measurements of the weather and the climate. There are measurements from ships, aircraft, satellites. We have ground-based instruments, LiDARs, weather stations. We have radars. This is what a lot of the work that my group works in is radar and LiDAR and weather stations. And so you can see we have to put all these observations together in order to study and learn about the weather and the climate. And so a lot of my research is focused around trying to improve the weather forecast. So this is the group that I'm currently working. And you can see on the left here, this is an image of, this is an actual computer model. So it's a supercomputer that we run. It's actually run in Montreal. And the supercomputer produces this very detailed image and then forecast of all the weather that's happening on this grid every day. So this happens every day. And essentially what this does is this provides your weather forecast. So you can take a certain location and look out several days and say, hey, what's the weather going to be? And my job is try to improve this. If we see issues, what can we do to improve those issues? And one of the things that's happening right now is as computers get more powerful and as we get better and better supercomputers, there's more information that we can put in. So this is called resolution. We can improve or increase our resolution. And if we look at what this means for Toronto, so if I look at the city of Toronto and I have a 10-kilometer resolution, so 10 kilometers is a huge space, and I say, okay, I'm going to have my computer run at 10-kilometer resolution. Well, you don't really see that much. Toronto just looks like a big flat tile. But if I increase the resolution to 2.5 kilometers, okay, now I'm starting to see some features. It's not just a tile. I see lots of tiles covering Toronto. And if I get to very high resolution, let's say 250 meters, so this is less than a kilometer, well, now I can see a lot. I can see the Don Valley River. I can see where Lake Ontario is pretty flat, and I can see here's the hill as you move away northward in Toronto. And this helps us improve our weather forecasts if we want to look at extreme heat, intense precipitation, so lots of rain, winds, lake breezes, air quality, as well as lake conditions. And you can see the impact if we look at this, for instance. This is clouds at low resolution, 2.5 kilometers. So these red blobs are clouds. And these are clouds at high resolution, 250 meter resolution. And what we can see is once we go to higher resolution, it does a lot better job at reproducing what the satellite actually sees. So this is a satellite that took a picture of the clouds above Ontario. There's Toronto's right here. And this looks a lot closer to the high resolution model than it does to the low resolution model, which means we can then do a better job at predicting where is it going to rain, how much is it going to rain, and so forth. So my project working at Environment Climate Change Canada was part of the Canadian Arctic Weather Science Project, where we equipped 2 sites in the Arctic and subarctic, one in Whitehorse and one in Iqaluit, with a whole suite of instruments that could measure weather and climate. So we call these super sites. And we selected these sites because Iqaluit is a hotspot for shipping transportation. So that's all these green and yellow lines that you see them moving across the Arctic, as well as they're hotspots for severe weather. So these are the storm tracks, these arrows that you see here that move across. They sort of hit Whitehorse and then they move across from different directions in some case, and then they hit Iqaluit. So they're great for studying severe weather. Think of blizzards, very strong flooding, those kinds of events. So Iqaluit is here in the Canadian Arctic. It's on the sea, so it's a coastal site. This is the airport at Iqaluit, and so our site is located right next to the airport, which then helps our observations that are useful for the airport as well. So if you're a plane coming in for a landing, we can use our data at the airport as well. So this is what Iqaluit looks like right in front of the airport, and this is about October. You can see there's no trees, and it's turning to winter very quickly, so there's no grass even. And we have a number of instruments at the site that were taking different observations, everything from water vapor to radiation to clouds. We were imaging individual snowflakes and particles, winds, and so forth. There's a lot of work setting up a super site, as you can imagine. We need to set up all of our computers and servers inside the buildings. We need to use lots of equipment like cranes and so forth to set up the instruments. That's what you can see in these images here, and it's hard work doing it in the snow. And as I mentioned, you're working in very, very cold conditions. So you're freezing cold, but then you have to use your fine motor skills, your hands to get in and do the electronics and so forth. And we had a second site at Iqaluit. So this is up on the ridge. This is the town of Iqaluit down below. And so we had a site up high where we put one of our LiDARs, and it was measuring winds and clouds and aerosols and the weather. And then our super site is at the airport down here. And it's important because that gives us multiple perspectives of what's happening in and around the city. But as I mentioned, if you have a snowstorm, here's our super site down near the airport. And I'm trying to get into my building here and look at the amount of snow that came after a blizzard. So you can't just walk in and do your work for the day. This day for me started a little atypical. We had to spend hours digging ourselves out of the snow just to get into my office, my container, which held my instruments, just to take a look at what was happening. So it's very different when you're working way up in the Arctic, but it's a lot of fun. And this just shows a time lapse of what our instruments do. So this is our LiDAR in the foreground. In the background, way far away here, that's our radar that was operating at Iqaluit. And you can see the LiDAR spinning around like crazy, almost like it's out of control. Well, that's because I fast-forwarded time. But what it does is it scans and it moves around to image and look at all the winds and the aerosols in the atmosphere, not just over the runway, but in every direction, above the city and around the city of Iqaluit. And I'll just end with one of the last images. This is we had a high-powered LiDAR set up at Iqaluit. And this LiDAR operates at a special wavelength that actually operates at the green where green light occurs. So if you like Star Wars, this is kind of like the Death Star green laser, except we're shooting a laser upwards into space. And as that laser reflects off of the water vapor and aerosols in the air, it comes back down into our LiDAR, and it let us measure water vapor, clouds, aerosols, pollution, smoke, everything that was happening above the site, way, way, way high up, all the way up to about 10 or 15 kilometers or so. And what's unique in this picture in the background is you can see this is the Northern Lights. So we got a really cool picture of the Northern Lights happening above Iqaluit, which is green and kind of yellow and white sometimes, at the same time as we were shooting a LiDAR up into space. So thanks very much. That sort of quickly covers some of the work we're doing in the Arctic and the work that I've been working on to try to measure the climate and weather in the Arctic. If you have any questions, please ask away.
Very cool. Zen, thank you so much, man. This was it's just an amazing presentation every time we have the chance to feature you. And I love the emphasis you put on the journey it takes to get there and sort of the challenges, but also excitement of such a special part of the world. Not many scientists or people, for that matter, ever get to go up to these places. And it's a really special opportunity to highlight to students sort of what science can look like at its coolest. So as you said, we're going to dive in with questions. If you can't see us, feel free to come out of screen share and so you can.
I can see you. Perfect.
Oh, perfect. Cool. I'm going to head to our classes. Everyone, if you want to unmute your mics, I will come to you one by one. YouTubers, if you want to share in the chat, please do. We'd love to take questions from you all. I'm going to head to Hilson Avenue Public School to kick us off. If you guys want to unmute and start with our first question, you are good to go. Hey, folks. Hi, guys. So you're in, but your audio is doing something weird. It was in before, but now it's not, and I don't know why. So play with it. Sorry for that. Worst case scenario, you can type in the chat on the side of the screen. I will come back in a second and see if that's working, but it was working just before we got underway. But I like your enthusiasm. Hi, guys. Mr. Tompkinson, 7/8. We're going to come to you first then in lieu of that. If you want to unmute your mic, I'm coming in.
Yeah.
Hey, folks.
Question?
Let's see. Hi, guys.
Okay. Notice, do you want to ask a question?
In the polar night, where is the moon?
Yeah, polar night, where's the moon? It's a great question. It's still there. Just in the photos, you couldn't see it in any of the photos. But you're right. So the moon's still doing its thing, same cycle as it always would. So during polar night, that's actually a good point. I think the only time we could see anything, and the brightest thing in the sky was the moon. So if you got a full moon during polar night, it was great because then all of the landscape became this kind of creepy, eerie, bluish white glow. So then you were kind of lucky. You're like, oh, okay, I can actually see a little bit. And then the moon would go away and you're back stuck in darkness. So yeah, it's still there.
To this day, the most unearthly video in any BBC series ever was in Seven Worlds, One Planet, when they went up to the Arctic in those sort of regions and filmed some of the wolves and Arctic hares up there. And the moonlight over the mountains up there in polar night is just like one of the most mesmerizing, wild-looking things, surely on planet Earth and beyond. So,
it's crazy. It's almost like you're on a different planet. It doesn't look normal, right? So
very cool. Hilton Avenue, take 2 with Feeling. I'm going to check in. Audio.
Hi, can you hear us now?
Yes, good.
Okay, perfect. But we've lost our camera, but we'll deal with it. So we have Kai here to ask a question.
Hey, Kai.
How many kilometers will you walk in a day?
Ooh.
Good question. When you're up there, it all depends. Sometimes we would do very little for a couple of reasons. You're very busy when you're up there, so you don't really have time to kind of, I'm going to go for a walk or a jog. The other reason is safety. So you're up there, you're all alone. There's no hospital, fire truck. You're on your own, so you can't just go for a long jog and wander off and I'm going to go for a walk by myself. You need to be very careful. There's a buddy system. You've got a walkie-talkie. Everyone knows where you are at all times. So you have, and then there's wildlife. You can get polar bears coming through. You can get wolves following you. So you have to be careful. Having said that, when you're up north and you're kind of stuck all together in this building inside long periods of time, you can get cabin fever, which means, oh geez, I got to get out of here. I got to stretch my legs. So we would go for sort of a nice sort of a group walk or a hike every once in a while. And then you can go for walks, several kilometers a day kind of thing. The snow slows you down. So you're in pounds and pounds of gear and boots and snow pants and goggles and yada, yada, yada. And now you're walking through thick snow and you can't really walk fast if, you know what it's like walking through, the snow on your way to school after a blizzard. So you can't really, and it's cold, so you can't go too far, but it's good and healthy to try to get out there and walk, several kilometers if you can.
I love the different places you took that answer. Thank you for that very much. We've got like wild animal risk. We've got buddy systems. We've got slushy, relating to school. I love it. So thank you for that question, guys. We haven't got that one for one of our scientists in a long time. We're going to head to Guelph Holy Trinity first, and then we're going to go to Mr. McEwen's horde of Calgarians because there's so many of you kids together, which is very exciting. But 4-5, Miss Cazola's group, come on in. Hi. Hi.
What's your question? When you had to drink water, was the water frozen, or how'd you have to drink water?
Yeah, great. Was the question how did I drink water up there?
Yeah, how do you get it? Is it frozen? Are you making your water? What's the deal?
Yeah, great question. So what they have to do at the site is they've got their water. It starts frozen, and then they have to melt it and thaw it and purify it and clean it and do everything that they can at the site. So the concern is there's not that much water. So you can't just say, I'm going to have a 20-minute hot shower, because then they're going to run out of water. So you have to ration it and be careful with your water supply. They also, of course, ship bottles of water. So you're always okay that way. But if you go for a hike, or if you go to the lab, or if you're just, I've got water in my backpack and I forget. Well, after just a few minutes, this has happened numerous times where, okay, I'm thirsty. I'm going to reach in my bag and take up my water bottle, and it's a cube of ice. And there's actually a really cool experiment. You can look up some photos on Google of people who, if you take a boiling hot cup of tea or water, you can go outside, and if you just throw it in the air, it's boiling hot, and you step outside, you throw it in the air, it instantly poofs into sort of ice and mist and fog, and it doesn't even reach the ground. So you can do experiments up there. It's so cold, the water will freeze instantly. So I've had a friend on a roof try to pour boiling hot water on my head, and it just instantly turns to sort of a fog, ice crystals, and won't even touch you by the time it won't even reach the ground.
And my plug du jour is if you're going to try this, don't pour it on your friend's head, wherever you might be joining from, and do it with a parent. But it's very cool. It's one of my favorite science experiments in the world. I did it growing up as a kid. Just make sure you're safe with something like that. And I know we've got some Ottawa folks today. So Ottawa, you guys know well how cold it can get to be. It's basically the northern reaches of this planet, but in our capital city. So check that out in the winter if you get a chance a little bit later on. We're going to head to our fantastic 3 classes together, Mr. McEwen's group, Mackenzie Lake School. If you guys want to come on in, we're going to take 2 questions from you, and then we'll do a whole other round with everybody. So welcome in Alberta, guys. Hi.
You can go there. Lottie?
My name is Lottie, and what is the oddest weather you've ever experienced?
Ooh.
The hottest?
Oddest.
Strangest weather, Jen.
Yeah, good question. I think the hottest weather was in the Arctic. I'd been up in Iqaluit and it hit, I think it was like 20 degrees something. So that's really hot for Iqaluit. Like you're walking around in shorts, t-shirt, sandals. But I've been in hotter weather for meetings and stuff in, let's say, around Hong Kong where it's, 35, 38. It can get really hot down there too, right? But it is odd for the Arctic to be that warm or that hot in the summer is something, it's unusual.
It's why we've got climate change scientists going on. Because this is something that, again, and I've been harping on this our entire series long, but I mean, when I was a kid, we talked about climate change. It was like, oh yeah, climate change, it's going to happen in like 2050. And like, oh, we're worried about that in the distant future. And like, ask any one of your parents or teachers and talk to them about how different the weather is now than when it was 20 years ago. Like Toronto, where I grew up, is radically different in the winter than it was when I was a boy. And this is something that we're seeing all over the world. And again, you kids know this stuff. You know climate change. You know the facts. And it's a really special opportunity to get to talk to some of the people like Zen who get to go up and understand that firsthand and are the people who brought us back that information that we use to sort of shape our understanding of the world around us. So I love that question, guys. We're going to head back to Calgary. One more question for you guys. And then Hilson Avenue, I'm back to you for part 2. Come on in, Mr. McEwen's class. Hi, guys.
Hi, I'm Lily. I was wondering, what piece of equipment do you have is the hardest to use?
Ooh, good question. That's a really good question. This is going to sound almost silly, but the hardest piece of equipment we've had to use up in the Arctic is just a tiny wrench, about this big. And I'll tell you why. So it sounds silly because it's a wrench, right? That's pretty much the easiest thing you could use. But when you're up there, it's minus 50. So now it's freezing cold. And a small wrench means I can't use my big, we wear mittens on top of this big mitten. So you can't use that because you're not going to be able to get in there with your fingers. So now I have to take off my mittens and I'm freezing cold. And so I'm trying to touch a metal screw to a metal plate to a metal wrench, and I'm trying to screw it in with a wrench. And so what happens? Well, my fingers start freezing. My fingers are now sticking to everything because everything's freezing. So I have to wrench it once, run inside, put my hands against the heater, let them warm up, run back outside, wrench it again until I can't bear it anymore, run back inside, put my hands against the heater, let them heat up. So it's something that, here it's a wrench, it's easy to use, but when you're up there, it becomes a 1, 2, 5 minute job. And it's very, very frustrating. It's not fun.
Sounds like what my wife has to do all winter long with any tool she uses. Just the heater is like our best friend for 4 straight months. Hilton Avenue Public School, I'm heading to you guys. We're going to do another round. YouTubers, don't be shy. Feel free to share any questions there as well. I'd love to take some from you. But let's head back to our Hilton Avenue folks. Fingers crossed. No. Your audio did it again. The moment you switched over to the camera again, I don't know why. I'm sorry. This is the joy of technology. Something should go wrong. So play around with it, flip the camera maybe, and deactivate that device, and we'll get you back in 2 quick seconds. But we'll go to Mr. Tompkinson's class while we're waiting. Come on in, 7-8. Hey, guys.
Go ahead.
How far can you see the LiDAR laser from?
Ooh.
Yeah, I think, how far can you see the LiDAR?
LiDAR laser. So if you were like to look at it from distance, is it hundreds of... Yep, space. What's the deal?
That's a good question. So that LiDAR is really cool because when you're up close, it's bright. and you can see pretty much if you lay down on the ground and you look up, you can kind of see it. It starts off as a straight line, and eventually it just kind of becomes a point because from your angle, you can't see it keep going up. So you can see it really far up, like kilometers. Now, if there's a cloud or fog, okay, you'll only see up to the cloud face until it hits the bottom. But yeah, you can see it up really high. So actually what they do is if you're in a plane and if you're coming into a Iqaluit, let's say, and that LiDAR is running, people from the plane can see that whole beam. Like it's like a perfectly straight green line all the way up and down. But that's also why we have to turn it off. So when a plane lands, we have to turn it off because that's dangerous. You don't want to mess up the pilots, and that beam will really, really hurt you and damage the plane if it flies through it. So we have to be careful.
Very cool. Thank you for that image and neatness. Hilson Avenue, you're doing some cool stuff with tech. You're upside down now, so I'm going to come to you, and hopefully the audio works, because it doesn't matter if you're upside down. We like you anyway.
Can you hear us now?
Yes, I can.
Awesome. All right. So here's upside down Khalid.
Hello, my name is Khalid. And how shocked were you when they asked you to go to space?
Oh.
So we had reviewed the thing about you being one of 32 people before this. So he's eager to hear a bit about that.
Yeah, for sure. So that's one of the great things about this field of science and physics and research is it opens all these other doors. So the Canadian Space Agency had an open call. They said, who wants to try out to be one of the next astronauts? So I said, I've always wanted to be an astronaut. Let's give it a shot. So luckily I already had all the education and you need to know math and science and all this stuff. And I already had the background. I was already involved. So I said, okay, let's give it a shot. So I had a ton of fun. It was a really cool experience. The Canadian Space Agency basically tests you on all these different trials. You have to do everything from a math test to a problem-solving test to how well do you get along with other people. And then you have to do a whole bunch of physical tests. So imagine being in the gym, you're running as fast as you can for as long as you can, and then they shove you in a classroom and say, now write this 3-hour, 4-hour long exam, and you have to do all the math questions. And then they pull you out of the exam and they say, okay, now we want you to swim in the pool for half an hour. So it was really, really cool. It was a lot of fun, and I got an excellent chance to meet a whole bunch of other Canadians who were trying out to be the next astronaut. So it was just a really fun, cool experience to try out and meet some of the other people and all the different backgrounds of people doing different things and pilots. So yeah, it was a lot of fun.
To clarify for our kid too, so Zen hasn't been to space. There were astronauts selected in that thing, but gets to go to the next best thing on planet Earth, which is the remote high Arctic. However, we do have a Canadian Space Agency astronaut coming up in a little over a week. So if you want to check that out, Jenny Gibbons is joining us. And we do have an astronaut, Jeremy Hansen, who's going to be going around the moon next year. So it's going to be the first astronauts to go around the moon in 50 years. And one of the Canadian Space Agency astronauts gets the chance to do that if you're keen on space as a follow-up to this Hilson Avenue. So
yeah, they'll give you a much better, more interesting answer. There you go.
I don't know. We've talked about your experiences before. That was a very cool thing. And thank you for sharing that. Ms. Gazzola's group, we're heading to you, and then we're going to wrap up with 2 more from Mr. McEwen. So 3 more questions. Folks, come on in Guelph. Hi, guys.
Hello.
Hi.
What kind of food do you guys eat?
Ooh, what do you eat?
Yeah, great question. Before I went up there, I was really worried because I thought, oh no, I'm going to have to pack, I don't know, ham sandwiches and peanut butter for months. But actually the food up there is excellent. So they try really hard because you're working so hard and you don't have time to cook. What they try to do is there's a chef whose job is to make everyone's food. So the chef makes these amazing meals, and they're big meals, because one thing that happens when you're working a lot and it's very cold. So what happens is your body is burning a lot of energy. Your body's burning a lot of calories. So when you come in for dinner, everyone's starving, and I would eat 2 dinners. So I'd have 4 meals a day. And the chef would prepare everything from, chicken fingers to grilled cheese to steak. crab legs, salads, macaroni and cheese, pasta. I mean, it was everything. It was amazing. Yeah, the food is incredible. You think the food's going to be bad, but it's actually amazing because they need to make sure you're well fed. Now, what happens is as the days go on, if there hasn't been a shipment in a while, well, then you're having canned vegetables, canned beans, but it's worth it.
Sounds worth it. It's funny. We get this question a lot for really remote expeditions, whether it's like on the ocean in the middle of nowhere, like high to high Arctic. And quite often the food's amazing. So this is a lesson to you kids. You'll eat better than you ever have in your life if you become a scientist at the edge of the earth. So there you go. Crab legs galore.
Definitely.
Mr. McEwen's class, we're going to wrap up with 2 more from you guys. Quick note again, if people want to check out the whole Changing Planet series, we've got 2 more tomorrow and the next day at 12 Eastern. And you can check out this program again on our YouTube channel when you're done. I'll also follow up with all our teachers with a neat wrap up when we're done as well. But come on in, Mr. McEwen's group. Take us away with the first one. Hi.
Hi, my name is Grant, and my question is, have you ever been so close to an animal you can touch it?
Ooh.
Yeah, good question, Grant. So yes, short answer is yes. What's really cool when you're up there is, for the most part, these animals have never seen a human before, so they're really curious. They're not afraid of us, and they're more just curious. They're like, hey, what is this thing, this weird smelling thing covered in all this weird plastic and coats and stuff? So yeah, what we try to do though is we try not to touch them, just because we don't want to interfere with nature, and I don't want to maybe bother the animal kind of thing. Also from a safety standpoint, the wolves look like these nice fuzzy furry dogs that, oh, it wouldn't be nice to pet them. You don't want to pet them. You want to keep your distance, and you have to respect them and respect nature. But having said that, yeah, you have come within touching distance easily of fox. There's something called a muskox. If you don't know what a muskox is, look up a picture, because they are very interesting, dare I say, somewhat ugly kind of animals. I don't know, but they're really cool. They're really cool.
I don't know. I'm a big muskox fan.
Okay, sorry.
They're kind of a shaggy, smelly beast, though. They're kind of the epitome of shaggy, smelly beast. So you should check out a muskox. They're very, very cool. Folks, this has been a lot of fun. One final question, and then we're going to bring everyone in for a big thank you and farewell. Mr. McEwen's class, we're wrapping up with you. Hey, guys.
My name is Everly, and how can you breathe if there are no trees?
Ooh.
Hey, that's a great question. So you're right. There's no trees up in the Arctic, right? So there's other foliage. So there is other grass and plants around, shrubbery and stuff like that comes out in the summertime. But what happens is essentially all the oxygen created by trees, let's say in and around Ontario, Calgary, Toronto, it gets circulated. So even though the tree might be far, far, far away from, let's say, the high Arctic, the oxygen that it produces doesn't just stay next to the tree. It moves around with the wind and it gets circulated. So all the oxygen eventually gets circulated around the globe. So that way we don't end up with sort of pockets of the earth that don't have oxygen. But that's a really good question, because you're right. There's not a lot of plant life up there. So
yeah. It is worth noting too, about 2/3 of the world's oxygen comes from algae in the water. So most oxygen on the planet comes from oceanic things instead of just trees, which is very, very cool. So I like when we get this question. It doesn't happen very often, but I appreciate it very much. Zen, this has been so much fun, man. What an amazing life you've had the ability to lead. Again, if you end up a scientist in your own life, you get to work with amazing people. You get to go to really cool places. You get to share it with people in a really enthusiastic way. So for any kids that are interested in being a scientist, I mean, there's a lot of cool stuff that you get to do in your life by virtue of doing that. And we really appreciate you joining us today, man, to share all your stories. And yeah, thank you so much. Is there any last message you want to share with our kids before I bring them in for a big thank you and goodbye?
No, just exactly that. A big thank you. This was really great talking about all this. And yeah, just remember that, the doors are always open, and there's lots of different ways you can go with, this is one path I took, but there's a lot of my colleagues work with supercomputers, work with instruments, don't travel. You don't have to travel if you don't like to travel. So there's a ton of options and flexibility as long as you keep your options and your doors open. So thanks very much.
Thank you very much, then. As you know, we're going to wrap up the broadcast with bringing in everyone. Hope you guys can check our next Changing Planet series programs. But I'm going to bring in our right side up, Hilson Avenue, Mr. Tompkinson's class. We're going to bring in our Kazola crew, and then the 75 bazillion kids in Mr. McEwen's class. Welcome in, everyone. Thank you so much. Have a wonderful day.